the early 20th century, London was at the height of its influence as the capital of one of the largest empires in history. The population of the city was growing rapidly, and public transportation was greatly expanding. Tramways were under construction, motor bus services began, and large-scale electrification was carried out. The city's first coal-fired power station, named Fulham Power Station, was commissioned in 1901. During the First World War, London experienced its first bombing raids carried out by German Zeppelin airships, but this was merely a foretaste of what was to come. Much like the rest of the country, London suffered from high unemployment during the Great Depression of the 1930s. However, the city's second coal-fired power station was built, named Battersea Power Station. Following the Great Depression, London, as did many other cities, suffered severe damage from bombings in World War II. After the war, London's rebuilding was slow to begin. In 1951, the Festival of Britain was held, marking an increasing mood of optimism and forward-looking. During the 19th century and in the early half of the 20th century, Londoners used coal to heat their homes. This method of heat generation produced large amounts of smoke. The coal used after the war was relatively low-grade, sulfurous variety, which increased the amount of sulfur dioxide in the smoke. This was due to an economic necessity of better quality coals being exported. During this time, the Greater London area had two more coal-fired power stations, including the Bankside Power Station and the Kingston upon Thames Power Station, which greatly increased the air pollution in the area. Air pollution also came from vehicle exhaust, particularly from London's diesel-fueled buses, which replaced the abandoned electric tram system. Winds also blew heavily polluted air across the English Channel from other industrialized areas of Europe. These sources of air pollution, in combination with climatic conditions, often caused a characteristic smog, and London became known for its typical London fog, also known as pea soupers, because of the yellow-black color the tarry particles in the soot gave the smog. London was sometimes referred to as the smoke because of this. Smog is a common form of air pollution typically found in urban areas. The term refers to any type of pollution regardless of the source or composition. London smog consists mainly of soot, but it also contains large quantities of fly ash, sulfur dioxide, sodium chloride, and calcium sulfate particles. When the concentrations become high enough, sulfur dioxide will react with atmospheric hydroxide to produce sulfuric acid, which can cause skin irritations and breathing problems. The particles coming from the factories and power stations themselves can be poisonous. However, they also act as a catalyst for fog as water clings to the tiny particles to create polluted fog. London smog is different than photochemical smog, as it is not due to a chemical reaction of sunlight, nitrogen oxides, and volatile organic compounds in the atmosphere which produce airborne particles and ground-level ozone. On the 4th of December, 1952, an anticyclone settled over a windless London, causing a temperature inversion with cold, stagnant air trapped under a layer of warm air. An anticyclone is a large-scale circulation of winds around a central area of high pressure. The temperature inversion occurred because the radiation from the surface of the Earth exceeded the amount of radiation received from the Sun because of a clear sky. This created a net loss of long-wave radiation and cooled the ground. A temperature inversion combined with sufficient humidity in the cooler layer produces a fog below the inversion cap as the moist air is cooled to its dew point pressure. This fog, mixed with smoke from chimneys, particulates from vehicle exhaust, and various other pollutants from industrial plants and power stations, blanketed the city of London the next day with a layer of smog 200 meters in height. The lack of significant wind allowed the blanket of smog to last from Friday the 5th to Tuesday the 9th, allowing for unprecedented levels of air pollution to accumulate. 1,000 tons of smoke particles, 2,000 tons of carbon dioxide, 140 tons of hydrochloric acid, and 14 tons of fluorine compounds were released into the atmosphere before the smog cleared. In addition, 370 tons of sulfur dioxide were converted to 800 tons of dangerous sulfuric acid. Although this caused a major disruption due to the effects on visibility, it was not thought of as a significant event at the time because of London's previous smog events. The effects on London over those 5 days were significant. Visibility was reduced to a few yards, making driving difficult or impossible. Public transportation was halted and ambulance services stopped. The smog even infiltrated indoor environments, forcing many events to be canceled. In the weeks following the event, medical services found that the fog had killed 4,000 people, with most of them being very young or elderly. Over 100,000 people became ill because of the effects the smog had on the human respiratory tract. Recent research suggests that the total number of fatalities was significantly higher, at about 12,000. Most of the deaths were due to respiratory tract infections from hypoxia, which is a condition when the body is deprived of adequate oxygen supply. The lack of oxygen was a result of a mechanical obstruction of air passage from the pus coming from lung infections due to the smog. This demonstration of smog's lethal potential has changed environmental legislation since 1952. The City of London passed the Clean Air Acts of 1956, leading to a reduction in air pollution. Households using coal to heat their homes were offered financial incentives to switch to gas fires. Factories were required to convert to smokeless fuels. However, insufficient progress had been made to prevent another smog event exactly 10 years later, in early December 1962, taking 750 Londoners' lives.